Alright, welcome. This is the second video for section 5.5, and what we're going to be working on is a few sample problems. The first video was just about how did they get formulas and what are formulas. And this second part is to actually do some formulas or do some problems with those formulas. So these are a couple of homework questions. I'm going to start with number 4. And if you look at number 4, you want to pull your book out, your unit circle, and then your formula sheet. Number 4 gives you this picture. Okay, so they draw a triangle. It's a right triangle. Theta is the angle of elevation. And they give you that the opposite side is 1 and the adjacent side is 4. And they ask you, find the exact value of the trig function. Number 4 asks you, what is the sine of the double angle? Okay, now we're going to use the formula. The formula for a double angle for sine is 2 times the sine of the angle times the cosine of the angle. And I would start every question too with what formula you're going to be using, because there are so many formulas in this section. And so here's what I'm going to do. All right, I need to know for sine and cosine the hypotenuse. So I have that 1 squared plus 4 squared is going to equal the hypotenuse squared. So 16 and 1 is 17 is the hypotenuse, and when I square root it, I get the square root of 17, and 17 cannot be broken down. Okay, so let's talk about this. I have, if I fill in the formula, 2 times, what's my sine? Sine is opposite over hypotenuse, so 1 over the square root of 17, and I'll deal with that in a second. Cosine is adjacent over hypotenuse, so 4 over the square root of 17. And now my job really is to just simplify. So this is like saying 2 over 1. So let's multiply the numerator. 2 times 1 times 4 is 8. 1 times the square root of 17 times the square root of 17 is just 17. So my sine of my double angle is just 8 over 17. Pretty nice. So that's the first one that you want to look at. Okay, the second one I want to look at is number 42. And I'm just trying to give you kind of a range of some questions that are coming up. Now, number 42 says, use the half angle, so we're doing half angles, to determine exact values of sine, cosine, and tangent of a given angle. Now, I'm going to only do sine, but our goal is to find the sine of 165 degrees exactly. And that's the biggest problem. 165 degrees is not on our unit circle. And so we have to figure out, is there a value on the unit circle that deals with 165? Well, here's how we're going to look at it. They tell you to use a half angle. And what that means is basically 165 is the same thing as 330 divided by 2. And so we're going to be using this half angle formula for sine. So the formula we're working with is the sine of our half angle of x over 2. Okay, the sine of our half angle is plus or minus the square root of 1 minus the cosine of x all over 2. Okay? So our goal is to now figure out what to do with this. All right, so 165 degrees. Here's what we got to go look back at. 165 degrees is in the second quadrant. Because this is in the second quadrant, is sine positive or negative? Sine is positive. So I only want the positive version because 165 would give me a positive sign. So I square root 1 minus. Now my x value here is going to be this angle that I'm working with. So I'm going to work with 330 degrees, so this is my x. So it's minus the cosine of 330 degrees, all divided by 2. All right, cosine of 330, we go to our unit circle, and we end up getting 1 minus the square root of 3 over 2, because cosine's positive in the fourth quadrant, all over 2. And my goal is to simplify this as much as I can, and your book has a hard time getting to simplifications that we like. So we're going to kind of show you. I don't want to leave a fraction in the square root. So instead of dividing by 2, what I want to do, actually let's do it this way. I'm going to make a common denominator on top. So I'm going to multiply the top by 2. So what I get is 2 minus the square root of 3 all over 2. And if I divide this, 2 divided by 2 is 1. And if I divide this, I get minus the square root of 3 over 2. And I don't love this answer, but this is the answer we're going to leave it as, because the more we try and simplify, the worse this is going to get. Okay? Now the goal again is to be able, do you understand what angle to use in your half angle formula? Do you understand, is it positive or negative? And then can you do a little bit of simplification? Now let me move on. We're going to do a couple more. Take a look. I also want to look at number 76. Number 76 says, use the sum to product formulas to write the sum or difference. And they give you the sine of 3 theta plus the sine of theta. Now, let me go back. You want your formula sheet to be able to figure out, okay, this is a sum to product. So I look at my sum to product, and here's what I'm looking at. They know that the sine of one angle plus the sine of another angle is 2 times the sine, let me try that again. 2 times the sine of my angles added together divided by 2 times the cosine of my angles added together divided by 2. And so this is what we're working with in formula land as we go through. Let me change my formula though and make it correct. It's x minus y. I apologize. Okay, so take a look. Here we go. I put in 2 times the sine. If I add my angles together, 3 theta plus theta, I'll divide that by 2. Cosine of 3 theta minus theta, all divided by 2. All right, 2 times. Well, 3 theta plus 1 theta is 4 theta. 4 theta divided by 2 is the sine. And I don't need this parentheses. Is the sine of 2 theta times 3 theta minus theta is 2 theta. 2 theta divided by 2 is the cosine of theta. This then is the answer that they are looking for. And all it's asking you to do really is, can you use the formula to simplify it down? We're not going to now train, our goal is not to use double angle to do more. It is just, can you simplify it as far as you can? Okay, now I'm going to need a little bit more space. You know what, I'll do this. Let's do the last one, 98. Number 98 says verify the identity. And they give you cosine to the 4th minus sine to the 4th equals the cosine of my double angle. Okay. All right, here we go. I am going to factor this. This is a sum of squares. So this is cosine squared times cosine squared. This is a negative sine squared times a sine squared. And my goal is to get to the cosine of 2x. So I have cosine squared plus sine squared, and I have cosine squared minus sine squared. Oh, this is not working. I apologize, my pen is acting up on me. Cosine squared minus sine squared. All right, well, let's take a look. Cosine squared plus sine squared is the Pythagorean identity that says it's equal to 1. Cosine squared minus sine squared is the double angle, so this is the cosine of 2x. So 1 times the cosine of 2x is the cosine of 2x, which equals, we drop this down, the cosine of 2x. And so you'll have to do some of the identities also, using these sums and formulas and all of the different things that we gave you in this section. But this is the bulk of the idea, and I wanted at least to have a couple of questions for you to see, so that you knew how you were supposed to use the formulas. So that's the last part of section 5.5. Again, try if you can to do some of the homework before you get to class.